It may sound strange, but we have mapped and studied the surface of Mars in greater detail than the ocean floor on our own planet. Sounds crazy, right? But it's true. We have mapped Mars with a resolution of about 5 meters per pixel. And we have mapped Earth's land in even more detail, about 30 centimeters. But when it comes to ocean floor, our maps are super blurry, only about 1.5 kilometers per pixel, which means it's 300 times less detailed than our maps of land. 71% of the Earth is filled with water, but still we don't have a proper map of our oceans. And that's a huge problem because we rely on the oceans all the time. We lay cables across it to carry internet traffic, fight wars in it, get food from it, and use it for global trade. In this video, let's find out why we don't have a proper map of our oceans. But before that, we have to know how we map our oceans. The ocean surface isn't perfectly flat. It actually follows the shape of what's underneath, even if only a little. Earth's gravity isn't exactly the same everywhere. So above a deep trench, the sea surface dips slightly, and above a mountain, it bulges a tiny bit. To map the ocean floor, satellites send radar pulses to measure the height of the water in different places. From these measurements, scientists estimate the shape of the sea floor, similar to the way topography is shown on Google Maps. This map shows the parts of the ocean floor that we have actually mapped. It really highlights how much the ocean floor we still haven't explored. And what about all those dark areas on the map? There are places where we don't have any detailed maps of the ocean floor yet. Mapping the ocean is shockingly hard, largely because they are just so much deeper than most people think. Okay, let me explain. At just 10 meters deep, the human body experiences twice the air pressure it feels on the land. At 214 meters, and you have passed the record depth for a person diving without equipment. It's already dark, cold, and dangerous. And by 1000 meters, the ocean becomes a completely different world. No sunlight reaches here. It's total darkness. And you are still less than 10% of the way to the bottom. At 1220 meters, you are at the depth of the deepest military submarines. By 3800 meters, you have reached the Titanic. The pressure down there is more than 350 times than the pressure at the surface. The deepest point on the Earth is called the Challenger Deep, and it's about 10,935 meters below the surface. To give you an idea of how deep that is, if you could place the Mount Everest upside down into the ocean, its peak would still be more than a mile below the surface. The satellite radar method we use to map the ocean surface doesn't give a clear picture of the ocean floor. It helps us to get a general idea, but there's still a lot of missing details. What you're seeing is basically an educated guess, a good estimate of what the ocean floor might look like based on the data we have. For example, look at these bumps and ridges. We know they are underwater mountains, but if you try to zoom in, the image becomes blurry because we simply don't have enough data to show what's really there in detail. We need better ocean maps for many important reasons. They help us to navigate the deep ocean safely and lay undersea internet cables more accurately. They can also save lives by helping scientists predict tsunamis, storms, and sea level crises more precisely. And with better maps, we could even find new ways to use the ocean for renewable energy. To make a more detailed map of the ocean floor, the Seabed 2030 project was launched. Its mission is to map the entire ocean floor by the year 2030 with much higher detail than ever before. Right now, most maps have a resolution of about 1.5 kilometers, but Seabed 2030 aims to map even the most remote areas down to 800 meters and busy or important zones down to just few meters. No one has ever done this before, but Seabed 2030 stands out for two big reasons. It's collecting data from news sources, including oil and gas companies, environmental groups, and even military. Seabed 2030 is also using cutting-edge ocean technology to make this possible. One of the most exciting developments is the rise of underwater robots, also called autonomous underwater vehicles, AUVs, or simply underwater drones. These machines can explore the ocean on their own, collecting data and scanning the seafloor. Scientists even call their scanning pattern mowing the lawn, because the robots move back and forth, mapping one strip of the ocean at a time. Some people worry about what might happen once we have detailed maps of the ocean floor. They think that if we find valuable minerals or resources, it could lead to destructive mining or exploitation. But the truth is, Knowledge isn't a problem, it's how we use it that matters. Avoiding exploration out of fear won't help anyone. Instead, we need to learn, explore, and use what we discover wisely.